Hello everyone, this is Mr. Ege, and in this particular session we're going to be designing a vertical wind turbine using the AutoCAD 2024 or 2023, whichever you have. Most of my students there right now 2024, and you start basically the AutoCAD. AutoCAD, one of the oldest CAD systems in the United States and in the world. Most commonly used one as well. And usually when you start AutoCAD, one of the few things you want to check it out, and you make sure that first your workspace is either 3D or two-dimensional. Your workspace actually is going to be at the bottom corner, and there is a very nice icon. When you click on the lower right-hand corner, the gear icon, okay, it shows you whether it is a 3D model or 2D, 3D basic or drafting or annotation, okay? And we're operating in the front view, so I'm going to just switch to the front view right now, and I'm clicking on my view cube on the top right-hand corner. This is one of the things you should be doing. And second, you're creating a 3D poly. Before we do that, let's check the units, what the units are showing, and I believe I set it up to my default units to inch system, okay? If you go to A on the upper left-hand corner, the red A, and there is multiple options over there, okay? Drawing utilities. And inside the drawing utilities, when you move your cursor over, okay, and there is going to be a new dialog box is going to appear, and you select the units, and units are resetting to units, engineering units. Engineering units is inches and highly precise, up to 10 thousandths of an inch precision, 0.0. But this is we prefer to do it. This is an engineering work. Precision is important, and okay. Cool. And so far so good. Second, limits is a very big deal, and we go to limits command by just simply typing limits, and I'm used to type the commands, English names of the commands, because I've been using this from the beginning, almost the beginning of the AutoCAD. Limits is a rectangle, and you're defining a rectangle by the XYZ coordinates. And particularly its lower left-hand corner, traditionally I accept 0, 0, enter, and upper right-hand corner, if it's bigger than 6 inches, I will take it. This is 6 inch, approximately 6 inch by 6 inch vertical wind turbine blade. This is what we're drawing, vertical wind turbine blade, and we're going to 3D print this as well. And this is about the correct size, 12 inches. Okay. And enter. Okay. All right. So the first command is make sure that you have the front view in front of you. And Z and X axes are showing in the front. All right. And if you can change the direction of your view cube on the top right corner, you're able to see X and Y and Z axes. And X axis is the length, the Y axis is the depth, and the Z axis is representing the height. Okay. And first command is a 3D poly. 3D polyline is a any polyline that you can draw anywhere in the space. There's a regular line command that you can only create on the XY plane. But because we are working on the 3D world, 3D poly is the correct line type. Okay, so I'm typing 3D poly. That's the name of the line command, three-dimensional line command, enter. And starting point is going to be 0, 0, so I'm typing 0, 0. X, that means first 0 is 0. first 0 represents the value of x axis, and second 0 is the value of the y-axis. Okay, in the three-dimensional world, default is z is also 0. Okay, every single point, okay, designated by 2 or 3 coordinate values that you put for three coordinates. So you enter at least 2 coordinates. Enter. Now, next point of the line is going to be 0, 0, 6. So I'm going to just exactly type that. 0, 0, 6. Enter. Okay? And enter again. That ends my comment. Second time enter ends my poly command. Poly. Now, thumb reel, when you roll back the thumb reel, okay, it's a zoom out, roll in, zoom in, roll back, zoom out. When you press the thumb wheel, you can move your line, your screen, left and right, up and down. When you press it, it becomes a hand. So that's called panning option. Okay, very good. So we created a 3D vertical line that's going to be the height of the vertical turbine blade. Okay, and now we're going to generate a 2-inch long line on the x-axis. Okay, so you can enter 3D poly. Okay, 3D poly, and enter. Okay, and the start point is 0, 0. Now next point is going to be 2 inches away from the start point on the x-axis. So I'm typing 2, 0, enter. Okay, is everybody clear on this? Okay. So you have a 2-inch line. By defining the line command, selecting the line command, and entering the first point of the coordinates of the xy coordinates of the first point and the second point, you have the line command. Okay, this is a typical way of creating lines. All right, you pick the first point, you pick the second point or last point of the line, and one line is created. And however, I want copies, 6 copies on top of the 7 copies on top of that. Okay, and separated by 1 inch away from each other. All right. So how do I do that? I can make a copy, multiple copies, or I can use the array command and do everything in one shot. If I can use the copy command, it will make only 1 at a time, 6 copies. But instead, I want to use the array command. And 3D array, absolutely. So I'm going to use the 3D array command. I'm going to type 3D, okay, array. Okay. What is 3D array? 3D array makes multiple copies at multiple directions. Okay. Enter. So it says select the object. So I do select my 2-inch line. Enter. Okay. And it's asking me whether it is rectangular or polar, but at the same time, inside the chevron mark, there is an R. That R means that if I hit enter key, by default, it's going to accept the rectangular array. Array is copy, basically, multiple copies, instant multiple copies, okay? And when you choose a rectangular pattern, it's going to be rectangular pattern. But if you choose a polar pattern, it's going to be circular pattern, circular copies, okay? We don't want that. We want the rectangular, so press enter key. And now it's going to be asking you how many rows, okay? Rows, as you know, okay, the number of the horizontal copies, okay? And rows is 1, so I'm going to accept that, enter. How many columns? Again, I want 1 column, okay, because it's 3D world. How many? Okay, enter. Now it's asking me how many levels. Levels is like how many floors on the Z direction. Oh, I want the 7, okay, so 7, enter. Boom. Specify distance between the levels. Okay, 1. 1 inch is good. Enter. And instantly everything is created. Isn't that cool? Yeah. So basically you have the 7 lines, okay, on top of each other, separated 1 inch from each other, okay? All right. This is the interesting thing about AutoCAD. Having being the oldest system on the planet, still, if you know exactly what the right commands are, you made a plan ahead of time for the right commands before you design something, and then it works instantly, and it's like a magic, very quickly, efficiently. Um, you have to have some certain amount of experience to make a plan before you start a design. Okay, just like similar the way you have, in order to start a construction, you have to have extensive plans, actual construction of the buildings, planes, ships, spaceships, and so on. But drawing is also a kind of construction. You have to make a plan ahead of time in your mind. And what I do is I even write it down before I explain something. Okay. All right. So this is a common practice. I am just demonstrating to you that how you do it. And as you're going to follow the instructions, you're going to get to learn it, get the feeling of how everything works, and it's going to be pretty easy for you later on to design something new. Okay. Um, so here's what I'm going to do. This is finished. Now we're going to type the user coordinate system. Do you see that XYZ mark at the very bottom? The name, proper name in the AutoCAD terminology is UCS. We call this the UCS, and there's a command called UCS. That UCS actually is controlled by the UCS command. So basically you type UCS, enter, enter, okay? That takes you original XYZ, okay? Plane. When you type UCS, enter, enter, it gets you right there, okay? And I'm gonna click on the front view. And yes, and right now I change my view to the bottom view, okay? And why it is doing that, right? That, so that I can have the XY plane in front of me. Okay, I want to have the XY plane in front of me. Why do I do this? Regular lines are created on the XY plane, okay, unless you have designing the 3D polylines and so on. So I want to create an ellipse here, okay? And the ellipse I will create. Let's find out where the ellipse is first of all. No, it's not here. I can, all right. Ellipse, yeah, center ellipse. I'm choosing the center ellipse. And now you need to find the midpoint of this line because it's asking you the center point here. And I'm going to turn the object snap, make sure that object snaps. Our ability, my cursor to snap onto the correct locations. Okay, midpoint. Okay, and midpoint is selected. Cool. So it will find the midpoint for me. Or if it doesn't, midpoint. Okay, I clicked on the midpoint. Now it says the endpoint, so I click the endpoint. And now I'm going to pick 2.5 inches away from the center for the ellipse to be created. 2.5 inches. And something like this. I type 2.5. Okay, good. So the ellipse is created. Why did we create this ellipse? Because we want to extend those lines to the ellipse. And the lines that we created, actually, they need to be extended. Okay. And so I'm going to use the extend command. I can type extend if I wanted to, or trim. I'm selecting extend command. So in the extend command, you need to select your boundary edges. So click on the boundary edges and select, then click on the ellipse and enter key. Now select the lines that you like to extend. Click, click, click. Excellent. Enter. Now I want to trim certain lines. So where are the lines that I like to trim? So extend, next command is trim. In the trim again, cutting edge has to be selected. I click on the cutting edge and I click on the ellipse, enter key, because ellipse is going to be cutting everything else. Click, click, you select everything comes out of the ellipse. Click, click, enter. Now the lines that you cannot trim off, just you can delete them because you don't need them anymore. Here and delete key. Okay. So far so good. I think we generated most of the things. We don't need the ellipse anymore. Ellipse is working. So click on the ellipse and delete key. All right. Now I want to show you the 3D view of this. Okay. And how do I do that? Click here to view cube. Oops. So crazy. Let's go out of control. Z enter, P enter takes you back. Okay. And plan is not like this. Top view. Okay. This is pretty much how it is. I'm going to change it. Orbit command. I'm typing orbit. Orbit. That's going to give me a better view of the entire design. Okay. And oops, like that. Enter. UCS enter. Previous enter. Orbit again. Sometimes orbit works better, and sometimes you click on particular points on the view cube. And I prefer view cube occasionally and orbit another time. Okay, so what are we doing? We did user coordinate system, we adjusted that. Okay, we did a trim command, everything is done. Extend command, we've done this one. Orbit command, we did this. Now there's a command called rotate 3D. This is there are two commands to rotate regarding to rotation. Okay, one of them is rotate 3D. It's a beautiful command. It enables you to rotate objects in 3D world. So I'll take rotate 3D, enter. And what are we rotating? We are rotating those 2-inch lines. No, it's more than 2-inch. Most of them are. Okay? So rotating these lines. Why are we rotating? Because we want to form a three-dimensional spiral in the space so that we can extrude a profile of the wind turbine. The extrusion requires a path line, and the path line is spiral. It's one of the most difficult, probably, shapes to construct into 3D world. Okay, so for that, I have to rotate, okay, those lines around the axis, z-axis. Okay, so it says select the object. Okay, now my rotation of the first line going to be enter. It's asking you rotation on what axis? Z-axis. Certainly, it's a z-axis. Click on that. It says specify a point on the z-axis. We pick the end point of the line where it touches the z-axis. Rotation angle, and I'm typing the rotation angle, 24 degrees. How do I get to 24 degrees? Okay, first of all, total rotation has to be 120 degrees. Why? Because we're going to have 3 turbine blades around the 360 angle. Okay, when you divide 360 degrees by 3, you get 120. 120, okay, degree can be obtained 1, 2, 3, 4, 5 at the increments of 24 degrees. So that's why we're rotating the first one 24 degrees, second one 48 degrees, third one is going to 72 degrees, then 96 degrees, then 120 degrees. I'm going to do this video on this one, okay? So I'm typing 24, enter. You see it rotated, very good. Hit enter key, 3D, rotate 3D will come back. You select the second line, click on that, enter. And now it's going to ask you what axis, Z axis. It says select a Z axis point. As you click on that, now it's asking you rotation angle. Rotation angle, what comes 24 plus 24 is 48 degrees. I'm typing 48, enter. Very good. Now enter again, rotate 3D comes back, select the line, click, enter, move your cursor over the Z axis. I'm sorry, let's do this again. Enter again, select the line, enter, and Z axis, select it like this. Select the Z axis where the line meets the Z axis, enter, and now you're entering 72 degrees. Why? 3 times 24 is 72. So 72, enter. Perfect. Enter again. This time we're selecting the next line, enter, and rotation again, Z-axis, select the end of the line, click, and we did 72 degrees. So 24 times 4 it gives you 96. You type 96 degrees, enter. Perfect. And the last one, enter again, rotate 3D command comes back, select the line, enter, pick the end of the line, click here. Let's do it again. Enter command, select the line, enter, select the Z-axis, then select the end of the line. Click. Now rotation angle is how much? 120 degrees. 120. Enter. Perfect. Ladies and gentlemen, we have a beautiful path line or footprint of a spiral. Okay. All right. And how do we create a spiral? Spline command will work. Spline, we can use spline command. Let's see spline command. See if it's going to work. Spline command, we pick the end of the line, and line command, we pick the end of the line, pick the end of the line, pick the end of the line, and enter, enter. Wow, impressive. Okay. So, orbit, enter. Okay. So, everything is done. You go to orbit to take a look at it. Okay. And change the angle. Look at it. Okay, this is the line that you want to keep. Okay, and I'm talking about this particular line. I'm going to exit. Click here. This is this particular line is going to be the extrusion path. Okay, so I'm going to end this session here because in the next session I'm going to let you to create a profile for the wind turbine and then extrude it alongside this line. Okay, so be patient and go with the second video after you finish. Up to this point, don't forget to save your work in the OneDrive. All right, have a great day.